Hello all. Today we will see new unit, that is unit number 3, memory management. In this unit particularly, we are going to study everything that is related to memory, how memory is managed, how there are different mechanisms to manage the memory, and so on. So let's start. The first very topic of memory management is address translation. In address translation, what exactly is happening, we will see with the help of a diagram. But before that, there is some basic introductory part. So let's begin. In real mode, 80386 segmentation unit shifts the selector left 4 bits and adds the result to the offset to form the physical address. What happens in real mode? There are different modes: protected mode, real mode, virtual mode. But especially when your microprocessor, that is 80386, is functioning in a real mode, or it is working in a real mode, then at that time, the segmentation unit, there is a unit called as segmentation unit. This unit, what it will do, it will shift the selector. Selector is nothing but it is used. What is the task of a selector? We have seen in the previous unit that it is used to select the entries from the different table or descriptors. Okay, so what it will do, select it will the segmentation unit will shift the selector. Now where it will shift the selector, it will shift to 4 bits left, means to the left side it will shift 4 bits, and after shifting left 4 bits, then it will add the result of the offset to form a physical address. Okay, but when your microprocessor is working or functioning in a protected mode, at that time, what it will do, it will transform logical address into physical address. Fine. Means what? Logical address means what? It is nothing but address viewed by the programmer. Very simple. Logical address means it is the address that is viewed by the programmer, and physical address means what? Actual address in the physical memory. This is very basic. We can say difference to keep in mind. Logical address is associated with the address that is viewed by the programmer, and physical address is the address or actual address that is in nothing but in your physical memory. Fine. So again, there are two parts of this address translation process. There are two parts. First one is nothing but the segment translation, and the second one is nothing but the page translation. Segment is different and page is different. Segment you can relate means what? There is a continuous block of memory. Sorry, there is a continuous stream of a memory, and when you are dividing the memory into chunks, that chunks are nothing but referred to as segment. And what is page? Page means you can relate a page to our notebook page also. So like that, there are different pages in the memory. So that is nothing but page translation. Okay. Now, what does this segmentation translation mean, or what does this segmentation or segment? It is not segmentation. It is segment translation. What does it do? It does it only. It is nothing but it is such a unit where a logical address is converted to a linear address. Logical address means what? Address that is viewed by the programmer. Linear address means what? It is nothing but the address that is to be mapped, or that is nothing but it is a pre-translated address. Got it? Pre-translated address. So it is segment translation. What work it is doing? It is doing the work of converting your logical address to a linear address. And logical address, it is given, it is logical address means what? It consists of a segment selector and a segment offset. This I will show you in the diagram now. Then after that, what is page translation? Page translation means what? Over here, the linear address is converted to a physical address. See, segmentation and page translation are actually working hand in hand. First is the segment. In the segment translation, your logical address will be converted to linear address. After it is converted to the linear address, it will come to the block of page translation unit, This unit will then convert this linear address to the physical address. Now how this is working we will see. This is a diagram over here. Now what happens in protected mode, every segment selector, this is nothing but your segment, sorry, this is nothing but your selector. Okay, so as it contains of the segment register. Fine. Every in protected mode, just mark this line. I am talking about protected mode. In every protected in protected mode, sorry, every segment selector contents of the segment register has a linear base address associated with it, and it is stored in the segment descriptor. It is nothing but segment selector will contain the contents of the segment register, and it, what does it have? It has a linear address, linear base address, and that linear base address is associated with it, and also it is stored in the segment descriptor. Now over here you can see there is a selector. Okay, then this selector is of how many bits? 0 to 15, that is 16-bit selector. It is associated with a logical address. Then this is nothing but the offset. Offset is having 0 to 31, that is 32-bit offset. Now what this will do? In the offset will be given to the segment translation unit. In the segment translation unit, basically there is one, we can say one process. What is that process? The segment translation after that will give the, once the process is carried over here, the segment translation will hand over the data to the paging translation unit. This paging translation unit, what it will do? It will, once it will get this segment translation, when once it will convert your logical address to the linear address. Over here conversion of logical address to linear address will take place. Once it will get the linear address, that linear address will be translated to the segment translation. Then the segment translation will hand over that data to the page translation unit. Now what does this page translation unit do? If the page translation unit, if it is enabled, okay, if it is enabled, then it will take the address and then it will come to the page translation section, and then it will go to, then it will do the conversion of linear address to the physical address. Okay, if your paging unit or page translation unit is enabled, then it will take the linear address from the segment translation. This linear address will be taken to the page translation block. Over here it will convert the linear address to the physical address. Okay, but if your page translation, it is not enabled, or it is what you can say, if it is disabled, then what will happen? There is a, see, this is a linear address block. How this linear address block is represented, you will see. It is having 32-bit linear address. dir means directory, page means your page normal, whatever is the page section in the memory, and this is nothing but your offset field. Offset, I repeat, this is nothing but your offset field. Now, if your paging mechanism or page translation section is disabled, then the linear address will be carried to this particular unit. After it is carried to this particular unit, what it will do? It will go to the page directory. From the page directory, it will search the entry of the page, and once the entry of the page it is selected, then in this page you will get the offset. Offset is nothing but showing you the location of your it will it will show the location in the memory. Okay, or it will show a particular location in the memory. So in short, there is a directory. This directory will consist the address of a page, and the page will consist the address of the offset, and offset will give you the location. Once this process is done, once you locate from the directory to the page and from the page to the offset, once this is done, then it will go to the page translation unit. Then from the page translation unit, it will convert the linear address to the physical address. This is nothing but the explanation of diagram. Now what points are written over here? Just these points are written over here. What it is written, I will just relate. I will just relate now. I'll just read. You just check according to the figure. Selector. What is this? This is nothing but a selector. See, again I'll repeat. It is consisting of a logical address. The selector is used to point a descriptor. Okay, there is a descriptor over here. The selector will point to a descriptor for the segment in a table of descriptors. Okay, what is the task of a selector? It is used to point to a descriptor for a segment in a table of descriptors. After that, the linear base address from the descriptor, whatever is the linear base address from the descriptor, it is then added to the 32-bit offset. Whatever will, once you locate the descriptor, okay, once you point to a descriptor to the segment, what is the next task? The linear base address from the descriptor is then added to the 32-bit offset. And once you add this to the 32-bit offset, it will then generate a 32-bit linear address. Okay, now after this, the address is generated. Then this process is known as but segment translation. Fine. Selector, it will, what it will do? It will point to a descriptor that is from the segment in a table of descriptor. Then the linear base address from the descriptor, it is then added to the 32-bit offset to generate the 32-bit linear address. Then it, after it will generate a 32-bit linear address over here, then further the linear address or whatever is this process that we carried, it is known as but segment translation or segmentation. Now if the paging unit is not enabled, now we'll come to the paging unit. If it is, paging unit is not enabled, means what? It is disabled. Then the 32-bit linear address. What is this 32-bit linear address? It will correspond to the physical address. Okay, but it will correspond to the, what it is said, it will corresponds to the physical address. But if the paging unit is enabled, I will just tell, if it is if the paging unit is found that it is disabled, it will correspond, the linear address will correspond to the physical address. But how it will correspond means it itself has to search and locate to that page translation. But how it will refer to the directory? Once it will search the page address in the directory, see, directory will locate the page, and after it locates the page will locate the offset address. Once it gets the offset will, what it will do? Offset is nothing but showing the location. Then it will go to the page translation, and then further the physical address will be defined. Okay, but if the paging unit is enabled, then what it will do? The paging mechanism will translate the linear address into the physical address. Over here, if directly the paging unit is enabled, directly it will take the linear address from here and convert directly to the physical address space. So this is nothing but known as paging translation. So this is illustrated in this figure, and there are some terms that we will see now with respect to the description of segmentation and paging mechanism over here. These are the points that I told just now. Now we'll come to the segment translation, very important topic. Now first we will understand the diagram. Okay, this is nothing but your diagram, fine, of segment translation. There is, come to selector, 16-bit selector. It consists of logical address. Okay, then there is a 32-bit offset. Offset is nothing but it will contain the location. Fine. Then after that we will come to a 16-bit called as a index. We have a index part over here, out of which 0, 1, 2, 0, 1, 2, and 3, these bits are nothing but These 4 bits, they are nothing but associated with the RPL, that is requesters privilege levels. So there are 4, 0, 1, 2, and 3, means total 4 privilege levels are there from 0 to 3. Fine. Then this TI is nothing but your table indicator. After that, we will come to this block that is called as the descriptor table. This descriptor table consists of the segment descriptor. Okay. Now, the segment descriptor, what this segment descriptor now it consists of, we will see. This segment descriptor totally comprises of access rights, limit, and base address. Totally, this is called as a segment descriptor. After that, further moving, we will have directory, page, and offset. Now we will see one by one each bit we will see now one by one. So let's start. Come to the selector. The selector, as shown in the figure, it is nothing but the segmentation mechanism. Okay, and it shows how selector is used to access a descriptor in a descriptor table. The very basic point, as I told in the previous slide also, the selector will just show, or it shows just how selector is used to access a descriptor, how it will access a descriptor in a descriptor table. This is a descriptor table. Okay, this is a descriptor table, and the selector will just show how to access a descriptor. Let that descriptor be of any type. Now over here we are accessing a segment descriptor. Okay, so clear what is the task of selector? It will just show, or it will just point how to select a descriptor from a descriptor table. That's it. Now we will move to the index part. That this index part is nothing but total of it is shown over here 16. Okay, it is shown 16, but out of that we will or the index is just defined as a 13-bit index. Just keep this point in mind, it is just defined as 13-bit index. So the 13-bit index part of a selector is multiplied by 8. See, this index part, it is nothing but multiplied by 8. Okay, so and it uses a pointer to the desired descriptor in a descriptor table. What it is having? Index part multiplied by 8, and it uses a pointer. Why it uses a pointer? To because it needs to point to the desired descriptor in the descriptor table. So it will have a pointer, and that pointer will show where it needs to point. It can be a segment descriptor, it can be a global descriptor, it can be a local descriptor, it can be an interrupt descriptor. So the pointer now in this position, it needs to point to the segment descriptor. So when you multiply the index by 8, then it has a pointer. That pointer will point to the desired descriptor, but in this case the desired descriptor is the segment descriptor. Okay, then why you need to multiply this index by 8? Because each descriptor requires 8 bytes in the descriptor table. Just this is a very important point. Why you multiply this index by 8? Because each descriptor, it requires 8 bytes in the descriptor table. So you are multiplying this index by 8. Then the descriptor in the descriptor table. Come to this point now. The descriptor. But in our case, what is the descriptor? Segment descriptor. So what this will do? The descriptor in the descriptor table will contain mainly base address, okay, segment limit, and then access right byte. A very basic part. It will have a base address, it will have the limit, segment limit. What is given over here? 20 bit. And access rights byte, it is 1 byte. Okay, the 80386, whatever is our microprocessor, it adds the base address from the descriptor to the effective address or offset to generate a linear address. What it will do? Once you once the pointer will point to the descriptor, then from the descriptor it will take the base address. It will take a 32-bit base address. And what it will do? What by taking of the while it will take the base address, 32-bit base address, this base address is added. What it is done? It is nothing but the microprocessor will add this base address from the descriptor to generate effective address or offset. uh, I'll just repeat. The base address is added, or the 80386 microprocessor will add this base address from the descriptor, where it will add to the effective linear address or the offset. Effective address, whatever is this effective address or the offset. But why it is doing, why it is adding to a effective address or why it is adding to the offset? Because it wants to generate a linear address. So this whole process, whatever is this whole process, why we are carrying this whole process? Because we need to add the base address to an effective address or to a offset in order to generate a linear address. And what is this dir, page, and offset? What is this called? It is nothing but a what you say, effective linear address or offset address, and this is the format of your linear address. Then we will come to next bit, that is index is clear, adding multiplied by 8. When you multiply by 8, this process is followed and linear address is there. Then we will come to this bit now, rp. Now what is this rp doing? Okay, rp is nothing but requesters privilege level. There are now total, as we had discussed, if you remember, there is a privilege level. I had told in the first unit, maybe 4 levels are there, 0, 1, 2, and 3, and they are all associated with the security purpose. Okay, so but now how these levels are used in this topic, we will see. This figure, what it will do, as shown in the figure, there is a bit. So the selector component of each logical address, this is a selector component of each logical address. It will contain 2 bits, 0, 1, 2, and 3. How much is shown over here? 3. Out of that, first 2 bits, 0 and 1, 0 and 1, this is associated with this requester's privilege level. Fine. So the 2 bits which represent the privilege level of the program section, it will represent the privilege level of the program section, requesting access to a segment. Now, why are you setting this privilege level? The basic meaning of privilege level means what? It is in order to, it is nothing but requesting you to grant the permission either to access a memory unit, either to access a segment, either to access a paging unit. So this requester's privilege level task is to grant permission or to grant access. Okay, so the this requester's privilege level consists of 2 bits. This 2 bit is nothing but why you are using, because it represents the privilege level of the program section requesting access to a segment. It will just request an access to a segment, that's it. Whether you can access that segment or not, it is decided, or it is seen by this 2 bits. Then the level 0 is the most privileged and the level 3 is the least privileged. There are 4 levels, 0, 1, 2, and 3. Out of that, level 0 is the most privileged level and level 3 is the least privileged level. More privileged levels are numerically smaller than less privileged levels. These are the facts or conditions that you should know or keep in mind, that out of 4 levels, 0 is the most privileged, third is the least privileged, and the more privileged levels are numerically smaller. Got it? More privileged levels are numerically smaller than less privileged levels. So this is a very important point to keep in mind. And then we will come to the another level, the descriptor of each segment. See, each segment will have its descriptor. Okay, it contains 2 bits which represent the privilege level of that segment. Even the descriptor, no, whatever is your descriptor, see, in this case this is our descriptor. Now this the descriptor of each segment it will contain the 2 bits, and again that 2 bits will represent the privilege level of that descriptor. Okay, when an executing program, whatever is a program that you are executing currently, it will attempt to access a segment, right? Why it will attempt to access a segment? Because there are some rights given to that segment. So whenever you are executing any particular program, then what it will do, it will attempt to access a segment, the memory management unit, etc. And at that time, when that particular program which is getting executed, it will what it will do, it will try to have get access privileges to the segment, or it will try to get access to the memory management. But at this time what happens, there is a comparison done. What type of comparison? Comparison is done between the privilege levels, that and those privilege levels are nothing but the privilege levels in the selector with the privilege level in the descriptor. I repeat again, whenever you are executing any program, okay, and if that program attempts to access a segment or a memory management unit, at that time there is made a comparison. What type of comparison? Comparison between the privilege levels, and those privilege levels in the selector with the privilege level in the descriptor. This is nothing but your selector, and this is nothing but your descriptor. So privilege levels in from the selector to the descriptor, they are both compared. And if the segment selector, what if the segment selector has the same or the greater privilege level than the memory management unit, then allows the segment to be accessed. Now when you are doing comparison, it is found that the segment selector is having a privilege level that is same or greater than the memory management unit. Then what it will do, it will allow the segments to be accessed only in this case. But if the selector privilege level is lower, this is if this selector's privilege level is lower than the privilege level of the segment. Okay, this is nothing but, suppose this is a segment. Okay, this is nothing but a segment. And if the privilege level of the selector is lower than the privilege level of any segment, then the memory management unit, what it will do, it will deny the access. Okay, and sends an interrupt signal to the CPU. It will clear cut cancel the request, or it will deny the access. And at when once it sends back the request, at that time an interrupt signal is sent to the CPU, indicating a privilege level violation. Very simple. I will just tell in one or two sentences that, now see, whenever you are executing a program, and that program, if it wants an attempt, or if it wants to access a segment, okay, then what happens, when if it means it is requesting that I want to access the segment, at that time the memory management unit, it will compare the privilege levels in the selector with the privilege level in the descriptor. If the privilege level in the segment selector has the same or greater privilege level, okay, if it when while doing the comparison, if it is found that segment selector has the same or the greater privilege level, then the memory management unit, it will allow the segment to be accessed. Then it will allow the program to access the segment. But if it is found that the selector privilege level is lower than the privilege level of the segment, what the program wants to access, it wants to access the segment. But if it is found that the privilege level of the selector is lower than that of the segment, then the memory management unit will deny the request, and it will send a interrupt signal to the CPU, indicating a privilege level violation, that I cannot allow the current program to access the selector. Okay, or sorry, access the segment. This is the whatever the description I gave just now, it is written everything in this further slide. Fine. And the table descriptor, last is the table descriptor bit. This bit, what it will do, this bit will just decode which descriptor table should be referred by the selector. See, this TI means table indicator. This table indicator, it will just do the work of decoding. And what it will tell, this bit will decode which descriptor table should be referred by the selector. Means it will tell this selector should refer the segment descriptor, or it will just tell so and so selector should refer so and so descriptor. Okay, so in short, it will decode which table descriptor should be referred by the selector. Which table descriptor should be referred by the selector is done by the TI bit, that is the table indicator. And this is nothing but its further explanation of the diagram. Fine. Thank you.